Assalamualaikum and hi everyone. We are going to talk about the application which is half rectifiers and full wave rectifiers. Full wave rectifier can be divided into two, which is center tap, full wave rectifier and full bridge rectifier.
What is a rectifier? A rectifier is an electronic circuit that converts AC voltage to DC voltage. It can be implemented using a capacitor-diode combination. The unique property of diodes, permitting the current to flow in a single direction, is utilized in here. Now, what is a bridge rectifier? Bridge rectifier is a full wave rectifier circuit using the combination of four diodes to form a bridge. It has the advantage that it converts both the half cycle of AC input into DC output.
Full wave bridge rectifier. In full wave bridge rectifier, a transformer and four diodes are used. During the positive half cycle of secondary voltage, the diode D2 and D4 are forward biased, but diode D1 and D3 do not conduct. The current is through D2 or D4 and secondary winding. During the negative half cycle, the diode D1 and D3 are forward biased, but diode D2 and D4 do not conduct. The current is through D1, secondary winding D3 and R. The load current is in the same direction in both half cycles. Therefore, a unidirectional DC voltage is obtained across load resistor. Since each diode conducts for only half cycle, the current rating of the diode must be at least half of the DC load current. Each diode must withstand a peak inverse voltage equal to the peak secondary voltage. Therefore, the PIV rating of the diodes must be greater than VP. As the output is a full wave signal, the output frequency is double the input frequency. Advantage of full wave bridge rectifier. Center tap on the secondary of the transformer is not necessary. Small transformer can be used. For a bridge rectifier circuit, PIV per diode is 1/2 of the value of each diode in a full wave rectifier. Disadvantage of bridge wave rectifier. In this type, two extra diodes are used. The voltage regulation is poor.
Center tap full wave rectifier. We have already discussed the full wave bridge rectifier, which uses four diodes arranged as a bridge to convert the input alternating current in both half cycles to direct current. In the case of center tap full wave rectifier, only two diodes are used and are connected to the opposite end of a center tap secondary transformer as shown in the figure below. The center tap is usually considered as the ground point of the zero voltage reference point. Working of center tap full wave rectifier. As shown in the figure, an AC input is applied to the primary coils of the transformer. This input makes the secondary ends P1 and P2 become positive and negative alternately. For the positive half of the AC signal, the secondary point D1 is positive. GND point will have 0 volt and P2 will be negative. At this instant, diode D1 will be forward biased and diode D2 will be reverse biased. As explained in the theory behind PN junction and characteristic of PN junction diode, the diode D1 will conduct and D2 will not conduct during the positive half cycle. Thus, the current flow will be in the direction P1, D1, C, A, B, G, and D. Thus, the positive half cycle appears across the load resistance R load. During the negative half cycle, the secondary ends P1 becomes negative and P2 becomes positive. At this instant, the diode D1 will be negative and D2 will be positive with the zero reference point being the ground GND. Thus, the diode D2 will be forward biased and D1 will be reverse biased. The diode D2 will conduct and D1 will not conduct during the negative half cycle. The current flow will be in the direction P2, D2, C, A, B, G, and D. Center tap full wave rectifier waveform. When comparing the current flow in the positive and negative half cycles, we can conclude that the direction of the current flow is the same. When compared to the half wave rectifier, both the half cycles are used to produce the corresponding output. The frequency of the rectified output voltage is twice the input frequency. The output that is rectified consists of a DC component and a lot of AC components of milliamps. PIV of center tap full wave rectifier. PIV is the maximum possible voltage across a diode during its reverse bias period. Let us analyze the PIV of the center tap rectifier from the circuit diagram. During the first half or the positive half of the input AC supply, the diode D1 is positive and thus conduct and provided no resistance at all. Thus, the wall of voltage Vs developed in the upper half of the AC supply is provided to the load resistance R load. Similar is the case of the diode D2 for the lower half of the transformer secondary.
Half-wave rectification. In half-wave rectification of a single phase supply, either the positive or negative half of the AC wave is passed, while the other half is blocked, because only one half of the input waveform reaches the output, mean voltage is lower. Half-wave rectification requires a single diode in a single phase supply, or 3 in a 3-phase supply. Rectifiers yield unidirectional but pulsating direct current. Half-wave rectifiers produce far more ripple than full-wave rectifiers, and much more filtering is needed to eliminate harmonics of the AC frequency from the output.